And number 2, we're given a plane. It's got 3 points. We want to figure out the vector, parametric, and scalar equations. All 3 of those need directions, right? Not points, we want directions. So we've got to turn our points into directions. We have choices here. I'm going to do AB, vector subtraction. So 2 minus 1 is 1, 1 minus 2 is negative 1, 1 minus negative 1 is 2. And I'm also going to do AC. Now you could totally do BC, nothing wrong with that, or you could reverse the order of these things and do CA and BA, or lots of choices here. 3 minus 1 is 2, 1 minus 2 is negative 1, 4 minus negative 1 is 5. So a vector equation for this plane would be pick a point, your choice, which point, A, B, or C. Any of those points are on our plane. I'm going to use A, and then I need my 2 directions. So direction 1 is 1, negative 1, and 2, and direction 2 is 2, negative 1, and 5. And there's your vector equation. If we want to do our parametric one next, just picking our parameters. So x equals 1 plus 1s plus 2t. Y would be 2 minus an s minus a t. And z would be negative 1 plus 2 s's plus 5 t's. Okay, to do the scalar equation, our scalar equation needs a normal. To get a normal, we have to do a cross product. So for our normal, we're going to have to do, let's call them s and t just for simplistic sake here, the cross product of s and t. So if we list s, negative 1, 2, 1, negative 1, we list t, we'll get negative 1, 5, 2, negative 1. Our cross product will be negative 5 minus negative 2. It'll be 4 minus 5. It'll be negative 1 minus negative 2. Or in other words, we get negative 3, negative 1, and 1. Now, our book often, as I said, we've said a few times, will make the x part positive. That would be the same, it's a scalar multiple direction vector, right? So 3x plus y minus z plus d equals 0. Pick a point. Your point could be A, B, or C. I'm going to use A. So 1, 2, and negative 1. So 1, 2, and negative 1. And if we add that all together, we end up with 3 plus 2 plus 1, which is 6. So 6 plus d is 0. Remember, d is negative 6. So our scalar equation for this plane comes out to 3x plus y minus z minus 6 is 0. And there's all part A. Part B, find another point on the plane. So if I want to find a point on the plane, the best way of doing that is by using our parametric equations. The x, the y, and the z, but you pick your values for s and t. We can pick any values we want to. So let's say s would be 2, and t would be 2, just for fun. Well, in that case, x would be 1 plus 2 times 2. In other words, I get 7. My y will be 2 minus s minus t, which gives me negative 2. And z would be negative 1 plus 2 s's, 2 times 2, plus 5 t's, which gives us 13. So another point on the plane, a point would be 7, negative 2, and 13. Okay. Part C. Determine the equation of 2 different lines that are contained by the plane. Well, for a line, we need to have a point and a direction. So let's think about this. We have 3 points. Right? I could use A, B, or C. And I need directions on this plane. Well, I already have 2 directions. There's one right here and a second right there. So if I want to make a line, I can do that really quickly, actually. I can use a point. Let's use A. So we're doing letter C here, okay? Letter A, which was the point, this is line 1, point 1, 2, negative 1, and use one of my direction vectors from previous. So one of the direction vectors I had was AB, so 1, negative 2, sorry, 1, negative 1, and 2, and there's a line. I can make a second line, or 2, by using a point. I can use the same point, nothing wrong with that, but just picking a different direction. So let's use the t part parameter, which was, I believe, 2, negative 1, and 5. I've got 2 lines. And you can make all kinds of lines, right? I didn't have to use point A. I could use B or C, or I could have used any vector that joined A, B, and C. So lots of choices how you want to approach that one. D, determine if the point 4, 5, negative 3 lies on the line. Oh, sorry, lies on the plane. Well, how can I check that? Well, the best way is by either using my parametric and solving for S and T. Well, that seems like a lot of work. Or even better, by using my Cartesian and plugging that in for X, Y, and Z. So 4, 5, and negative 3, and this Cartesian equation. So 4 for X, 5 for Y, and negative 3 for Z. Well, if that point's on the line, this equation has to come out to 0. And if we try it, we get 12 plus 5 plus 3 minus 6, which is 14. Well, 14 doesn't equal 0, so that point is not on the line. Okay, that's the fast way. Now, I said you could use your parametric. There's nothing wrong with that. It would just take a lot more work, that's all. Okay, E, determine the equation on another plane that's parallel to this plane. Okay, well, it didn't tell us what format we can put this in, so we have a bunch of choices here. I think the easiest thing would be the Cartesian version of it, because if they're parallel, they have the same normals. And we know our normal already is 3x plus y minus z. Now, to make it parallel, that means the points have to be different, right? They have to be separated. So the only thing I can't put in for my d value is negative 6. You can put anything else in, any number you want right here. It just can't be negative 6. Because if it was negative 6, then they would be the same plane. And we don't want that. We want a parallel plane. And then part F, determine the angle of intersection of the original plane and the plane given by this new equation. Okay, this new equation right here has a normal of 2, 4, negative 1. We're going to change colors because that one is really hard to see. Okay, 2, 4, negative 1. Ours had a normal of 3, 1, negative 1. We know when two normals meet, that produces an angle. So for F, to find our angle, we're going to use our dot product idea, right? Normal 1 dot normal 2 over magnitude normal 1 times magnitude normal 2. That's what we've been doing over and over again. So our dot product will be between the two vectors. Okay, let's just write down the vectors here. Vector 1 was the one we got from our question. So 3, 1, negative 1. That's one we made. And normal 2, they gave us the second plane, was 2, 4, negative 1. 2, 4, negative 1. Okay, so let's do our dot product. We'll get 6 plus 4 plus 1 all over the root of 3 squared plus 1 squared plus 1 squared, which is root 11. And 2 squared, 4 squared, and 1 squared makes root 21. And we can do our inverse cos of all of that. And our answer should come out to, if you do it properly, 46.4 degrees.